We are going to look at is how you can actually evaluate your classification based models, because what we're actually able to do now is actually for that of the on our previous video we're able to make use of neural logistic regression, which is actually one of that of the classification based model to actually train the logistic regression on this data that we have here. This is just a small amount of data that we have, so we just trained it on that our small amount of data. We use this testing data to that of the 20%, and for the training to be that of the 80%, that making it a total of 100% of our data. So we fitted the model length from that of the 80% of our remaining data, and then we tested it on that of the, we can say, that of the testing data, which is about 20% of our data. And when we ran it for our testing, we already have two rows of data that was saved behind or left behind for that of the testing purpose. So what we can basically do now is actually evaluate our model. There are basically many ways to evaluate the model, but we're going to look at the three best way out there that you can actually use to evaluate the model. The first is that of the accuracy score. After that of the accuracy score, we have that of the confusion matrix. After that of the confusion matrix, and have that of the classification report. So we're going to go each of them step by step with a formula that each of them uses. So in case if you're interested in, maybe you don't feel like using what Scikit-Learn provided for you, want to actually make use of that or the formula to actually solve your, or maybe write your own down. So let's start with that of the accuracy. When we look at that of the accuracy is definitely like trying to tell you that what was actually being predicted. How is it related to that? So what was actually being predicted? I can look at the correct. You can look at. They can say also look at it as the correct predictions divided by that of the total prediction. This actually makes sense because the correct prediction, because this we are looking at that of the accuracy. Accuracy is actually trying to tell us that, okay, how accurate is our model? How accurate does it tend to predict something? So let's say actually, this is my word pass. So it's more like for this of the accuracy, you can give the accuracy to be that of the correct prediction. It's actually CP for correct prediction, and that of the what total prediction. Simple as that. So that is for the accuracy. So remember that each of these guys also they are part of that of the Scikit-Learn metrics. So if you want to make use of them, you need to actually import them. So let's actually, since we have actually tend to understand that of the accuracy, remember all the correct prediction, not both the correct and the both correct and that of the not correct is falls under this of the total predictions, like all the prediction that I actually made. The correct ones divided by total let's assume that the correct ones were about, let's assume that there were total predictions, let's assume total prediction were 10, and then he predicted correctly for that of the 6. So no 6 divided by 10 definitely going to give you 0.6. If you times it by 100, if you want to turn it to that of the 100%, in case if you're interested in turning it to 100%, this is actually 60%. This actually makes sense because now we can see how well your model is actually doing. So let's actually look at our model. When we did our model, when we actually use the model to check the model probability, and we see that for the classification, for the threshold that we actually set it, this is actually 1.0, this is actually 100%, this is 99.99 from the data that we actually set for this. This is actually a classification based program. So let's actually look at the accuracy to see how accurate the model is. From the look of it, the model should be clocking almost 100% if I'm not mistaken. So remember that is actually also exists on this of the Scikit-Learn matrix. So you can say from this of, okay, we have a Scikit-Learn matrix really important, but let me actually just make use of them. Want to make use of that of the accuracy score. So we have this of accuracy score. Let me just import other ones. We have that of the confusion matrix, and have that of the classification, which is the classification report. Yeah, classification accuracy confusion matrix and that of the classification report. So we have done for that of the accuracy score, and something else you should know about how the parameter that how accuracy score actually works in that of the Scikit-Learn is this: the accuracy is that of the y true and that of the y pred. When I mean the y pred is what he actually predicted. This is just more like saying our y test. In our case is going to be test, our y test, comma our y pred. The reason why is our y test because we want to know that the y test is the actual target that was being reserved. This is actually the truth. When I mean the truth, I mean the true the true target that was not touched or was not predicted on by our model. So to do this, we can just come down here. Where is that? We can actually come down here and say print our accuracy score. But let's actually let me just say accuracy score. So let's see how accurate our model was. So we can say our accuracy is what's the accuracy score. So like I explained, is going to be that of the y test, which is the y true, and how that of the y underscore pred. Remember, like this variable that I gave you, this is what was actually predicted by the model, and this is the remember what we actually predicted was this of the x test that we actually predicted. So the y test is actually the true I say the true target if I'm not mistaken, true target, the true target, and then this was what was the model predicted by using that of the features of that of the x test. Let's actually run this and see. And also, before as we are running this, let's actually look at that of the confusion matrix. That of the confusion matrix can be a little bit different to that of the to that of the accuracy score. Let's actually close this. Let me actually open new one. It's actually supposed to be here. Let me actually open new one. Let me go to join. So let me drag this. Let me bring this here. So for that of the confusion matrix, how this confusion matrix is different from that of the accuracy score, like I explained, to use what is actually called that of the true negative, true positive, false negative, false positive. So this is actually the board, you can actually call it. This is actually true or true negative. Down here I have the true positive. Up here is all about the false positive. We have what is actually called that of the false negative. Don't worry, I'm going to explain all this, what all these things are. Remember that I said that this is actually that of the true negative, this is actually the false positive, true positive, and that of the false negative. But let's actually go back to see our accuracy score. You can see our accuracy score was a 1, which is 1 times 100, that's 100%. So if you are interested, you can actually put that of the times 100. If we run this again, we are going to get that of the 100%. So for that of the that of the confusion matrix, so we have this of the true negative, true positive, false negative, true positive. So what is actually this true negative? This true negative is the prediction that you made, that your model made, which at how many were true, that is actually true. This is just like saying, okay, the model predicted. Sorry, this is I'm talking about this true negative, not actually positive. Why did I make that mistake? This is more like saying that the true negative, when you predicted that this thing is actually false, compared to that of the true value, was it actually false? Let's say for this of the TN, let's say what you predicted was actually 0, and then the actual was also 0, and see that this is actually true negative. That's basically what true negative is. When the predicted negative and the actual was actually negative. So that's just basically what is true negative. The negative that is true. And then we'll have this true positive, which is TP Let's assume that you predicted what? You predicted 1, right? And the actual was actually 1. So this is actually true positive. What the positive that you predicted is actually the same thing with the actual. So that is actually that was true positive is, and for that of the negative, you predicted negative, and the actual value was actually a negative. So these two guys tend to explain themselves. These two guys, they are more like in change or in both of them. So that is actually for both of them. Saying with the understanding of these two, these remaining two guys should explain themselves automatically for you. So let's actually look at them. We have false positive. You already know what false positive. You predicted positive, but the actual is actually negative. So let's look at this of the FP that we have here. Let's assume that the P was actually you predicted positive, right? You predicted 1 that is named false positive, but the actual was actually that of what? 0. We see the ideology here. You predicted, this is what you actually predicted, 1, but the actual is actually 0. You see that this point your model made a mistake. So let's go for the next one, which is the false negative. Wonder why my this is like this. So false negative is when you predicted negative and the output and the actual is actually positive. So let's assume if this is it, you predicted what? Negative. I'm using this of the 0 to represent that of the negative and that of the 1 to represent positive. So false negative, you predicted what? Negative, but the actual was actually that of the what? Positive. You see how they all differ. This is actually what the confusion matrix is actually trying to tell you, that what you predicted, which of them were actually true and which were actually negative, and what did you predict right and what they actually predict wrong. So this confusion matrix can be really, really confusing if this is your first time encountering it, but nevertheless, as you go on, it's not going to be really hard to implement that of the confusion matrix. Let's actually go down. Let's actually come down here. So we can also say, because remember that when we come to this confusion matrix here, we actually let's assume this is the confusion matrix. You actually take that of the what? Y true. This is actually the true, which is the Y. In our case, is going to be our test. So the Y test, comma, and that of the Y what? Y bread. This is it. Y bread. Hope it enters. This is the Y bread. So to do that, let me just copy. They are basically going to be, but I'm going to move that times 100. So I'm going to move this. So here is going to be our what? Confusion. The name alone is confusion. So confusion matrix. Let's actually call it so this will be, let me just write it, confusion what? Matrix. Confusion matrix. I think this actually settles it. So let's actually run this confusion matrix. The confusion matrix is actually running. Let's look at that of the classification report. So the classification report just basically does so many things. It gives us that the score or the classification or the report of that of the I think that was precision, recall, and that of the F1 score. So precision is we can look at precision as similar to that of the accuracy, but they are not the same. When you look at precision is more like the true positive value that it actually predicted, which is this of the true positive value, divided by that of this true positive value plus that of the false negative value that is actually predicted. But let's get rid of this. So let me just open new drawing paint. So we're also going to look at that of the recall, precision, and that of the what is the last guy? I've forgotten the last guy. Precision, recall, and that of the F1 score. So let's actually look at our output. You can see that accuracy score 100, confusion matrix 1001. When we look at this from the look of this, from everything that we'll look at, Okay, I've got rid of that. But this is actually for that of the true negative, and this is actually for that of the true positive. So from our prediction, is you can find out that, remember that it's only just two prediction, and there were 0 and 1. So if we want to actually understand this really more, let's actually increase our test size. Let's increase our test size to 4 so we can actually understand the really more. But let's try to explain this. Still, when we see more data, it will make sense for us. So this true negative that we have here, what's this true negative is that it takes 0. Let's assume that 0 is the negative. So there were only one negative, and that one negative, he predicted it correctly, which is actually 1. And when we look at this positive, true positive, there were only one positive. I think this actually makes sense. When you look at this, only one negative and one positive. That's not actually, and he predicted it correctly. And then false negative, there's not actually false negative there. Maybe this is actually false negative, this is actually false positive. That actually is. So that is just basically. But when we change the test size to be that of the 0.4, so we'll have more maybe you can say more values. I can say more testing data that we are going to look at how that of the 4 true negative, true positive, and that of the false negative and false positive, how they actually can say align properly. So let's actually go back for our confusion metric. So when we look at that of the precision, is actually precision. Remember that, sorry, my handwriting is not looking good. Precision is that of the true positive that we have divided by the true positive plus what? That of the false negative. That's not supposed to be false, that's supposed to be false positive, because it deals with that of the positive side. But when we look at this true negative, true positive plus that of the false positive. This is precision. Is just trying to get how closely we can say, like I said, it can be a little bit similar to that of the can be a little bit tending close to that of the accuracy, but they are not the same thing, so don't get it confused. Let's say the true positive maybe was 2, for example. It's going to be true, and then for our true positive, definitely is going to be 2, and then plus our false positive, let's assume is 0. So it's going to be 2 divided by 2 is definitely going to be 1. So your precision is going to be 1. I can see that, like I said initially, that it can be similar to as if it's going to be that of maybe accuracy, but they are never the same thing. This precision mainly focus try to check how well can say how close you are to that of the you're actually predicting that of the what is actually true, and you actually predicted them to be true. Let's say assume 1, how many were you able to predict that is 1 that is actually that of the 1? So I don't even know how to even explain this, but for this smaller everything, just like trying to, like I explained, this is actually the true positive, the ones that are positive, and then all the positive stuff that you actually predicted. You are trying to divide it, the true positive divided by that of the true positive, and that ones you actually predicted false positive. Just like all the positive, the one you got correctly, and the positive, the one you predicted positive, but they are not positive. Then you get, that is actually what precision is. Like I said, it's almost like that of the accuracy, because not accuracy is actually the correct prediction. That's assuming, because this true positive almost like turning to that of the correct prediction divided by all the prediction made. But in this case, we're only looking at the positive side. That of the negative side does not get involved. And when we look at that of the record can be a little bit similar to this of the precision. The way record works is that of the true positive divided by this of the true positive plus that of the what false negative. So this is actually basically record. Record is just like trying to, the true that you predicted, trying to you can say divide it with that of the true positive plus that of the false negative. I don't even know how to explain this recall, but this recall is really important. But most of the time, precision is actually a good F1 score is actually good. This recall too. By looking, you should actually look at this record. But let's actually see that of the remember we changed our test size to be that of the 0.4. So right now we are getting this of the 2.0 and 0.2 like before we're getting 1.0. Then we'll have more data on our DC. Remember that now it's now 4 initially. Let me go down here. This was actually only 2. Where was that? No, this is not it. Let's not actually go up ahead. This is actually it. Only 2 rules that we actually use for the testing purpose. Now we now have, since I changed it to that of the 40%, now we now have that of the 4 rules for that of the testing of data. So for this of the confusion matrix, like I said, this is actually that of the true negative. The negative, remember that the negative here is actually 2, only 2 of them, and then how many we're able to predict correctly. Remember, if we look at this of our threshold that we actually set here, this is actually for 0, and this is actually for that of the can say 1. Yeah, this is actually for 1. This colon is for that of the 1. We did actually print out everything because right now they are not going to be 4 colons. Not actually 4 rows, not actually 2 rows, because what we're actually targeting here was actually that of the 2 rows we actually targeting. So instead of printing this, you can actually just print our spreads, where we will print our spreads, which is our prediction. So we can actually see from there, we can actually understand other things that happen within this of the spread. But remember that there are actually 2 2 negative from our data. You can actually also see that. Let's go up. So we need to actually print our S test to actually see that of the actually the data we are being sent in for testing, and then we're changing to see whether it actually predicted it well, because when we look at our accuracy score, we're getting 100%. So this actually, okay, let's actually print our S test. Let's actually print our S test down here. So we can see our what? This is our S test. This will be, let me just make it to go down. So here is going to be our what? S test. So this is our S test. We are going to see that of the S test, where we see that of the S test. So we are going to see of course that of the, so I also print that of the Y test too. Let me actually bring this down. Let's actually print Y test. So let's actually print what was being sent. Okay, knowing that we're printing it out, we're just basically going to use this one that is right here, because if we can get the row, we can actually just, this is a small data, so we can actually just map it to each of them really. So we don't need to actually make things even more I can say more complex than it already is. So let's actually run this. As it's still running, let's actually head over to our record. Like I said, record is that of the total positive. I said the true positive divided by the true positive plus that of the true false negative. And for that of the F1, it's called F1 what? Score underscore score. This F1 score is one of the most important when it comes to the F1 score. It makes use of this of the precision and this of the recall. So it's going to be, the formula is that of the precision times what? Times our recall. Divided by what? Our precision plus our what? Our recall. So this is the formula that we use to get our F1 score. So all this is the reason why I'm giving all these formulas, in case if you don't want to make use of Scikit-Learn, you want to actually develop all these things by yourself. You can actually find all these things. They are not actually that hard to actually implement, just that it takes time to actually implement. That's where all this library tend to make things better, like to make life easier. Like just somebody have written it already. What you have to do is just to take it and then implement it and then start making use of it. So that's just basically what this scaling actually does itself. So a body can actually implement all this. So we're going to look at this of the classification. By now, we should have gotten our result on this of the confusion matrix. So let's go up a little bit. This is our confusion matrix. So let's go up now. So now, like I said, we're going to have extra. Not going to be 4 rows of data because it was predicted actually for. So this is the S testing that was used for that of the testing. And then we have the first row he used was this of the A22 and that of the salary 2000. Let's actually go up to see that. We have the 22 and 2000. Do you remember that this S test, the model have never seen it before, and they predicted what for that? Where is the prediction? I predicted 0 for it, and then the next one was 3545, which is actually 3545 is actually this girl, and the predict and the is what was actually initially was 1, and then model predicted 1 for 18,1000 was actually 0, and the model predicted it correctly, and the last one was 45 6000, which is 45 6001, and the model predicted it 1. So I should have written that of predicted. So with this, the model was actually performing 100% accurate. With 100% accurate is not actually it's hard to see this kind of prediction output, because the reason is because your data, because this is what we're getting is 100 because data we're using is small, and if you look at it, the data is more like a linear type of data, and we tend to progress. Then I mean like you tend to progress, like there's you can, when you look at it, the pattern is just clear, more than enough clear here. 18, 1022, 2025. You can see that the higher the age, the higher the salary, the salary. So purchase, I mean, whether if you bought anything, remember, definitely as your salary is increasing, you are more likely to buy something else. So this is that's why our model was able to get to this 100. On a real life scenario, you can never have 100%. You'll even be begging to get at least 50%, because most of the time we're looking at 20%. To get 20% at times is even hard, not even up to 100% accurate. So back to this of our confusion matrix. Like I said, this is the true negative. There were two. Where is that guy? Let me go up. Yeah. Where is it? What we predicted? True. Where is it? Let me go up again. This is it. There. So from what we were able to see here, there were two positive, which is 1 1, and two negative 0 0. So that's why we have this of the confusion matrix to be true negative. It have 2, the true positive had 2. So it predicted, and this should be false negative. So this should be false positive. It predicted 0, and then for false negative, it had 0. So the model was actually performing 100% accurate. And like I say, in a real life, when we start making use of the real data, we'll be begging for 100, for 50%. If I'm not mistaken. This, like I said, because of the data we are using. Data is a small amount of data, and when you look at this is more like a linear. If we were to plot the graph for this of our data, we'll be having a linear graph. As the S progresses, the Y also does the same thing. So even a linear regression will perform 100% here, because there's a relationship between that of the age and salary. But when we use a real life scenario, like predicting football games, stock market, it's not a linear type of graph. Most of the times, the X side does not even have anything to do with the Y. Like, they are just messed up and they are scenario. So let's actually look at that of the confusion matrix. Let me actually just. Sorry, this is not confusion matrix, classification report. Okay, let me just copy this. This is actually classification report. So it's going to be classification our classification report, simple as that. So here is going to be our classification. That should be classification report. I was waiting for VS Code to tell me to write this, to bring out the option. So we'll have the accuracy, confusion matrix, classification report. So let's also look at this of our classification report. Everything that classification report makes use of, this is all basically what I explained: the precision, the recall, F1 score. We're still going to see that of the support, but these three guys are the most important ones. So you can actually, like I said, this is for the precision, this is actually for the record, this is actually for the F1 score. So let's actually run this, and then we can actually look at some other. Remember that I've actually explained that of the precision, the record, the F1 score, and some other things we actually did earlier, which is we are looking at that of the, where is the other one? The accuracy, that of the confusion matrix. So I remember that I said they are under that of the matrix, can say the matrix sub module on this of the Scikit-Learn that we are using. So I wonder why this is actually taking time. But I think with this, there's a whole lot of things that on this of the Scikit-Learn matrix. Okay, you can see that of the classification report. This is for the confusion matrix, accuracy 100%, and then classification. Like I said, we'll be having this classification report. We'll be having this. This is the report, precision, recall, F1 score, support. So the first guy, this is actually classification report. We have 1, 2, 3, 4, 1, 2, 3, 4. For that of the precision, we had 0, 1.1, 1.0, 1.00, 1.00, and the support is that of the 2. And the next one was the precision became 1. When we look at this, accuracy is actually that of the 1, micro average 1, 1, and that of the micro average. So this one weighted average. So when we look at this, we're actually getting almost 1, which actually signifies that of the 100%. If you are to convert it to that of the 100%. So if you actually want to do this manually, you can take pen and paper with this data that we actually have here. They are not quite much like how we did in our linear regression. Apply all these formula that we have here. It's definitely still going to give you this of the precision result, recall result, F1 result. For this of the support for the formula for support, I can't even remember much on this of the support, but F1 score, recall, and precision, they are more than enough for everything you want to actually do. So with this, we have actually come to the end of this video. So when we look at this logistic regression, there's still hold down for this logistic regression, because what we are going to do, the next model that we are going to use, the way it makes prediction can be a little bit different from this of the logistic regression. So in the next video, we'll be looking at what's actually called that of decision tree, make use of trees to actually make predictions. So in case if you're interested in learning that of decision tree, make sure to stay to the next video. I'll be happy to see. If you find this video anywhere helpful, subscribing won't be a problem. So I'll be happy to see you in that next video. Thank you for watching.